Hello guys, in this video we are going to talk about byte oriented protocols. The first one about which we are going to talk is BISYNC, Binary Synchronous Communication Protocol. BISYNC. Alright, now this protocol is a sentinel approach type protocol. That is, it is guarding things. Let us take a look on its frame at very first. This is the frame of BISYNC protocol. Alright, let me just go to full screen. Here you see in this protocol this type of frame is there. So you first of all have two SYN type of characters. There is written two SYN. This means synchronous characters. So you will be having two of them in the beginning. By the help of this synchronous characters, you will be denoting the starting of a frame. Then there is a starting of header. This SOH is starting of header. This is of 8 bits. Then there is header itself. Afterwards there is an 8-bit starting of text STX. Afterwards there is body. Okay, its length is variable because it depends upon the data that you will be getting from the upper layer, that is network layer in this case. And here afterwards body, it's ETX. This is also of 8 bits and this is ending of text. And at the last we have a 16-bit CRC, that is cyclic redundancy check. Alright, now why it is written that it is a sentinel approach? It is written that it is guarding things. So why is that? Look here, the header is being guarded by SOH and the body is being guarded by STX and ETX, that is start of text and ending of text. These two 8 bits are actually guarding the body. Same goes for SOH for header. Okay, this is why it's known as a sentinel approach. So this was about the frame format of BISYNC protocol. Now these two synchronous characters. Okay, now let's talk about these are special synchronous character. That's how beginning of frame is denoted. So in this particular protocol you will be noting that there is no ending of frame, there is only starting of frame. So how are you going to denote that this frame is ended here? When the next frame, the answer for that question is when the next frame will be starting, so these two bits will be coming, and when the receiver will see that another frame is starting, it will assume that the previous frame ends here and the another frame starts here. So this is how a frame will be denoted and distinguished. Okay, here looking at STX and ETX, these are special sentinel guarding start of text, end of text, sentinel guarding characters that guard body. SOH start of header. This DLE is written over here, data link escape. We are going to read about this on the next page. For the time being, look at CRC, cyclic redundancy check. It is an error detection method. Okay, moving further. Now, how framing error occurs in BISYNC protocol? We're going to look upon that thing. So here it is. If the STX of 8 bits is similar to the start of the body, then due to being two similar 8-bit characters, there's TWO. I'm sorry guys, there's TWO. Being two similar 8-bit characters, the receiver can misunderstand it as beginning of other frame and will assume that the previous frame ends here. Okay, now what does this mean? Suppose I showed you here the frame now, right? There is an STX here. Okay, now suppose similar type of character appears in the starting of body. Now there is a body, it is starting from here, ending here. Suppose this same 8-bit character appears here. So the receiver now will interpret it like this, that two synchronous, that is two same bits, two same bytes, two same characters are appearing here. Okay, now this will mean that a frame is starting, hence it will interpret that the previous frame ends here. However, that was not the case actually. This is an error, this is a misconception, and this will lead to framing error. Okay, do not assume that this SYN is something special that can't be occurring or can't occur here. This is just that two similar characters are there. Okay, this just means two similar characters will be there that will be denoting the start of text. That similar situation can also occur here. Okay, this will lead to framing error in BISYNC protocol. So this is what is written over here. For that, we have a solution termed as byte or character stuffing. So here we add one extra byte whenever the framing error happens. It is done by DLE in BISYNC protocol. DLE is data link escape. Data link escape. Okay. So whenever this situation will occur, suppose there the situation occurred. Alright. Here occurred. Okay. So what we are going to do, we are going to stuff a different character among these two similar characters. The source will do that. Alright, and by this thing we are going to reduce or eliminate the framing error. Alright, moving further, we have the second protocol of byte oriented protocols. It is point to point protocol, PPP. Okay, it is mostly used in WANs, wide area networks. Alright, now this is the frame format. We will be having a flag in the starting and in the ending that will be denoting or distinguishing a frame from the another. Okay, afterwards the flag from going on from here to here, we have address, then we have control, then we have protocol, then payload, then checksum, and then again flag, which will be denoting the ending of a frame. Alright, now this frame will be like this. These bits will be in this flag 0 1 1 1 1 1 1 0. Okay, so 0 6 ones and then 0. This is how the starting and ending of a frame will be denoted in PPP, that is point to point protocol. Talking about address, this will be of 1 byte, that is 8 bits, and it is going to be, they are going to be all ones while broadcast. Okay, the another one after address is control. This is of 8 bits at very first, and this will be having a constant value of this 11000000, that is 2 ones and afterwards all zeros. Okay, alright, so this was control having a constant value of 1 byte. Okay, next one is protocol. This will define the type of the data that has been provided to you via the upper layer. Okay, now this could be of 1 byte or 2 byte, that is maybe 8 bits or 16 bits. This is payload, the data or payload or body, you can say, the data that you are being provided via the upper layer. Now this it's data here. This data of network layer, it's data of network layer. Okay, now the maximum length of payload is 1500 bytes. This is the maximum length that a payload can have. However, it could be negotiated between the endpoints of communication. So if the endpoints are communicating to each other and allow each other to exceed this, they might do it. Okay, however, in general, it is 1500 bytes. Okay, afterwards it's 16 bits checksum, this is error detection, and at the end we have flag to denote the ending of a frame. Okay, this was about point-to-point protocol, PPP. We read about BISYNC protocol, we read about PPP protocol. Now it's time for the last, sorry, there is a correct, yes. Now suppose if flag sequence appears in payload, then one extra byte is added. Now if this flag sequence, this that is 0, 111, happens to appear somewhere here, then it will lead to framing error, right? How do we deal with that? So to deal with that, an extra byte, not bit, it's byte, extra byte will be added. That byte will be having some information regarding it. Okay, now we read about BISYNC, we read about PPP. Now it's time to read the last protocol of byte oriented protocols. It is DDCMP. Okay, DDCMP, that is Digital Data Communication Message Protocol. Okay, it's the last protocol. So let me show you the frame format. It's not clean here. This is the frame format of DDCMP protocol. Okay, you can see here it is almost similar to BISYNC protocol. You have two 8-bit synchronous characters in the starting that will be denoting that actually will be distinguishing the text, the frame. Then you have 8-bit class. I perhaps think so it is similar to protocol. Like, yeah, it is similar to protocol. That protocol was in the role of protocol that was in BISYNC will be accomplished here by class. Then there is a special the special 14 bits which are denoted as count. This is something that distinguish the DDCMP. Let's talk about it. Now this count will be telling how many bits are coming that will make a frame. So suppose there is coming a frame, how much bits are in there, how much bytes are in there, that will be consisting one frame. Suppose you have 10 of them there, so the count will be 10. Now the receiver knows that after counting 10 of them, it will be one frame. Okay, this is how it works. Afterwards it's header 42 bits, then body of variable size, and then at the end it is CRC. Okay, so yeah, it doesn't tells about the number of bits, actually it tells about the number of bytes. I'm so sorry about that. So it will be telling you about the number of bytes that are coming. So if there are 10 bytes arriving, if suppose your frame has 10 bytes, so you will be writing 10 here, you will be this will be having number 10. So for example, so when the receiver receives it, he'll know that the count is 10. Hence after receiving 10 bytes, that receiver is known to the fact that this will consist of one frame because of the count that he had. Okay, this was about DDCMP protocol. Well, there is a serious chance of error here. Okay, now if this gets modified due to transmission error, then the frame will be interpreted wrong. Suppose the count gets interpreted wrong, like if the count was actually for instance, suppose there was 10 bytes, so the count has to be 10. However, due to transmission error, that 10 got modified into 5. Suppose 10 got modified into 12 somehow, then the frame will be interpreted wrong. This will cause to framing error. You can hereby look at an example. Now it isn't there, it is written over here, modified, this 7 is modified due to transmission error. So now this 4, this is written over here 4, so 1 2 3 4, this will consist of frame. Then there was actually 5 over here, look at it, 1 2 3 4 5. However, Due to transmission error, this 5 got modified into 7. Hence, consecutive, hence, as a consequence, the frame was interpreted wrong. Now the interpreted frame will be 1, 2, 3, 4, 5, 6, 7 up to this. However, actual frame was up to this before 5. So this type of error occurs in DDCMP protocol. Okay. Now what transmission error is? While transmitting, if data gets corrupted, then it is called transmission error. We just read it about here that this 5 got modified into 7. This is also kind of transmission error, that your data will change while you are transmitting something. Okay, so this is about transmission error. Other points are, for reliable communication, errors must be detected and corrected. If you want to have a reliable communication on which you can trust, so these transmission errors must be detected and corrected. Error detection and correction are implemented either at the data link layer or the transport layer of OSI model. Alright. Now, what are the types of error that occurs? It is written over here, bit error and burst error. These are the two types. Now, simply bit error means when a single bit will be modified. However, in burst error, more than a single bit will be modified, that is 2 or more bits. Here you can see this 0 got modified into 1. This will change the data, and hence it's a bit error. Now here in bit error, only 1 bit got modified. As I earlier told you that in burst error there will be a lot of bits that can get modified. Okay. Now detecting the error. Error detection is done on the receiver side. Okay. Now, is there an error or not will be done at the receiver side. Error detection is to check whether received data is correct or not without having a copy of original data. So you have to, because you don't have the original data, of course. If you have the original data, then what is the purpose of that communication? So this is the challenge actually. You have to check whether there is an error or not without even having the original data. Alright, now how this challenge is dealt. So to detect or correct errors, we need to send some extra bits with the data. You will come to understand this point after reading redundancy. What redundancy is? Now look at here. Suppose this is your data. This is the data that you are transmitting. Now you will be applying some logic, some logical calculation, some algorithm which will, on the basis of data that is 1 0 1 0 0 0 0 0, on the basis of all this will be generating some bits. Okay, so it has a defined algorithm. This algorithm was applied on this data and this came out. Okay, understood? Very well. Now this thing that came out after applying a certain algorithm, this certain algorithm just simply means we did a bit of calculation to generate this thing. Okay, now why did we do so? First of all, know that this is redundancy check. These bits will be sent along with the data. This is the actual data. This all is actual data. This is redundancy check. These bits that we created earlier. Now, look very carefully. When the receiver will receive the data, he knows that this is redundancy check, so he will be keeping this apart at very first. Then after taking the data, he will apply the same algorithm, the same logic, the same calculation that the sender applied. That receiver is aware of what algorithm was there. So he will apply that same algorithm on the data. And if he receives that, if and when the calculation of what he applies, that the redundancy check that he gets after applying the algorithm on data matches with the redundancy check that was originally sent by the sender, if those two matches, then the data will be accepted. This means there is no error, because whatever algorithm the sender applied on the data gave out the same redundancy check as it gave in the receiver's case. So this implies that there is no error. This is redundancy check. Okay, so this whole theory that I told you is written over here. You can go through this if you want. Okay, I prefer you to go through it. Now we read about redundancy here. Here we have error correction. Now this is not much about error correction that is written over here. However, reading about it, it says receiver can have the sender read transmit the entire data. Now suppose there is a error in the data. You detect, first you have to detect the error in order to know that whether there is an error or not. Now you find one. Alright, fine. What to do now? There are two ways in front of you. Either you can contact the sender that please send retransmit me the entire data, because there happens to be an error in the data that you sent earlier. Okay, this is one way. The other way is the receiver can use error correcting code which automatically corrects certain errors. Okay, so one way was you can say the sender that please retransmit me the entire data. The other way will be to to applying some error correcting methods. We are going to discuss them later in the coming videos. For the time being, error detection techniques will be our entire focus. Okay, so there are four of them: vertical redundancy check, that is VRC, longitudinal redundancy check, LRC, checksum, and then cyclic redundancy check. You saw this earlier a lot of times. Huh? Now we are going to see what this actually is. We will be seeing this in the upcoming lecture, the next lecture. Alright. Yes, so yes guys, this was all for today. I hope you enjoyed this session. Thank you for watching.